Hello, we are now presently studying the global positioning system. As you might have already studied or gone through the theoretical part, now I will be covering the practical part of the global positioning system. In your practical, there are three exercises. One exercise is on handheld GPS, a demonstration handheld GPS, and the exercise which is for half an hour. And the exercise 2 is on differential global positioning system data collection, which is also for half an hour. And there is another slot of 30 minutes for on mobile mapping and location based services. Okay, now today we'll start with the differential GPS data collection. Before going to the field, I would like to just brief about what all the things we are going to do on the field and how we are going to proceed in the field. Okay, now we are trying to understand how to perform the global positioning system survey. Okay, so from the theoretical background, you might have now understood that receiver receives the signal from the GPS satellites which are orbiting around the earth at about 22,000 kilometers. And you also understand that you need to have the signals from minimum of 4 satellites, right? So that means to say that if you want to know the position of this point on the ground, you need to place a receiver over that point and try to get the signals from the minimum of 4 satellites. So these satellites basically transmit the signal and the receiver collects the signals, right? And upon analyzing, the receiver will be able to produce the location of this point. Okay, the location is given in terms of either x, y, z, or in terms of latitude, longitude and elevation. Okay, and also you understand from the theoretical background that these coordinates are in WGS 84, which is nothing but world geodetic system. Continue
नहीं इसी से स्टार्ट करेंगे जो
हाँ.
आपने दोबारा स्पीकर में इसके आगे
Okay, so we get the position in WGS 84, which is nothing but the World Geodetic System, which was established in 1984. Okay, so this kind of positioning we call it as the standalone in standalone mode. Okay, so however you get the position, but this position has got some errors. Okay, so these errors will make the positional accuracy to few meters. Okay, so now our aim is to improve this accuracy. How to improve the accuracy? Okay, so for that what we do is we go for another kind of surveying that we call it as differential global positioning system survey. In this, we say suppose this is your field where you want to know the position of this point, right, with an accuracy of few centimeters. Okay, right? So for that what we do is we take a point, right? We take a point on the ground surface whose xyz or latitude, longitude and elevation are already known to best accuracies. Okay, so then we place a receiver here and we place a receiver
here. Okay, so this point we call it as base, and this receiver we call it as rover. Okay, and the vectorial line joining this base and rover is called as baseline. Okay, so now our aim is to know this location to the best accuracies. Okay, so let me redraw this figure. So in DGPS, as we understand till now, we place a receiver on a known point that we call it as the base. Okay, and here is a point whose position is not known. Okay, so you place a receiver here, right? So these receivers will be continuously getting, say there are satellites orbiting. So these are the satellites orbiting around the Earth. So let me write it as a satellite number 25, satellite okay. So this satellite will be getting the signal, sorry, this rover will be getting the signal from okay, it tracks the signals from all the visible satellites, right? And it computes, say this is your known position, but apart from that, from this 4 satellites, this receiver can compute the XYZ, let me call it as the computed. Okay, now at the base you have 2 coordinates for the same point, right? One coordinate was which was known earlier with an accuracy of say higher accuracies. Okay, now this is the XYZ of the same point but computed from GPS satellites. Okay, these coordinates you can get it from benchmarks, or from the topo sheets, etc. Okay, yeah, so similarly at the rover end, rover also tracks the satellites. Right. So from these 5 satellites, the rover computes the X, Y and Z, right? So let me write it as XR, YR and ZR. This is basically to represent the position of the rover. So let me write it here as the B as a subscript, and overall bracket I'll write it as C here, basically because this is computed, and let me write it as K. This is the known coordinates. Okay, now our aim, now this coordinates will have an accuracy to few meters. Okay, now the accuracy, right? So this accuracy we have to bring it down to few centimeter. That is the aim of the present practical exercise. Okay, the question is how to get this. So yes, the question is how to improve the accuracy, right? In order to improve the accuracy, you need to bring down the errors to 0 or as less as possible, right? So this position it has got, let me write it as right, uh, so the accurate value of the rover plus the errors will be computed when you get the signals from the satellite and you compute the position, right? So here our task would be to reduce this errors, right? So you might have understood from the theoretical background what are the different kinds of error that you come across, right? So we need to minimize this. How to minimize this? The one approach is that you take the known position of the base, computed position of the base from the satellites, and try to get the difference of this. Okay, once you take this difference is nothing but x, y and z of this base which is known, right, minus x, b, yb, zb, which is computed from the satellites. Okay, right? So this is nothing but the error which I am talking of, right? These errors, if you look, then the total error budget is due to the different components, which I can break it down this way, right? The errors can be due to the ionosphere, the error can be due to the multipath, the error can be due to the satellite clock, or the error can be due to the receiver clock. So there are n number of reasons for getting this. Now our aim would be to bring down these errors. Okay. So now here I am just talking of the error in a very generalized sense. Okay. Now I know this, how much is the error from the base, and if I apply this correction, this error I can call it as the corrections also, right? So this error or correction will be applied at the rover, right? So once you apply, then from this computed you get the XR, YR and ZR which are accurate to few centimeters. Okay, so here the job of the base is to send the corrections to the base or compute the errors or compute the corrections, and then these corrections will be applied to the rover. Okay, so once those applied, then you get the position of the rover to an accuracy of to few centimeters or to the sub centimeters. Okay, so this is the basic philosophy behind the DGPS, right? So further talking more about the differential GPS, right? This can be done in two modes, right? One mode is we call it as real time, and the second one is the post processing. Okay, so in real time, so by this time you understand that you need to place a receiver over a base and a receiver over a rover whose position is not known, and here we know the position of the base. Okay, in case of, now we are talking of the real time. In real time, the base from the 4 satellites compute, this is the known. Okay, these satellites, they compute the XYZ. Okay, so the difference gives you the correction, and these corrections will be applied to the rover in real time. Okay, so for this, in order to apply the corrections in real time, along with the base, you need to have a modem which can transmit the corrections from base to the rover, and a rover need to have a separate antenna for corrections. So this modem will transmit the correction and the antenna will receive these corrections. Okay, and these corrections will be applied so that the XYZ at rover, now these XYZ are the computed XYZ from the satellite, so these corrections will be applied to this, right? Further, then you get the XYZ in centimeter level of accuracy. Okay, so this is the basic thing required for the real time DGPS, differential GPS. Okay, and regarding the post processing method, just place a receiver over base, okay, and start the survey. Okay, further when we go onto the field, we will see how the settings or how to start this survey. Okay, now over the base, so this base will get the signals from the satellites and it will store it in a file inside the receiver, and okay, so say this is a point whose position we have to find it out, and let me call it as the rover, right? You place a receiver here. Okay, this receiver also gets the signal from the satellites. Okay, this will store it in a file. Let me call this as the F1 and this is F2. Okay, so let us say that this is occupying for the time, say 10 o'clock to 11 o'clock time. For 1 hour you are occupying this particular point, right? And so if there are more points, then you need to place the receiver at different points. So this is the field. Okay, these positions are unknown, then you will be occupying the different points on the ground for different times, say 12 o'clock to 13 hours and 15 hours to 16 hours, something like that. So then the base also should be simultaneously getting the data. That means to say the base should be on from 10 o'clock to say 16 hours. So in order to apply these differential corrections, the base and the rover should be observing the satellites at the simultaneously. Okay, then these files F1, let me call it as F3 and F4, these will be stored in a rover. Okay, so after the survey is done, we go back to the office and we download this data, this F1, F3, F2, F4 into the system, okay, into the workstation. Okay, so using the software, processing software, these corrections which are computed will be applied to different points on the ground. Okay, once you apply the correction, then these positions will be accurate to few centimeters. So this is about how to do the differential GPS both in kinematic and in real time and the post processing mode. Okay, we understand that for real time you need to have a modem at the base and antenna at the rover, so that when the modem sends the corrections, it can receive the rover can receive the corrections in real time. And in post processing You just place a rover at a receiver at the base, and then start the survey, collect the file. Okay, and in the base also, in the rover you collect the file, another file, and this file f2 and the data here at the base will be collected at the same time, and process these two files in a workstation using this post processing softwares, right? Those softwares will apply the corrections from base to the rover, and that's how you get the very accurate uh, position of the rover. Okay, so now we are at the base station, right? We'll be setting up the base here. Okay, so we have got a mark whose coordinates we have calculated with the help of the other surveying works to a higher accuracies. So here is the mark. Okay, so here you can see a plus mark here, right? So this plus mark has we know the coordinates of this plus mark to a very higher accuracies, right? Now we will be establishing a base station over this mark, right? For establishing the base station we have the Leica instrument, right, which is okay. So for this differential positioning survey work, we have the Leica single frequency receiver, right? This is the receiver box, and in order to establish the base station we have the tripod. This is a tripod. Okay, now we will see the different components of this receiver. So this receiver system has got different components, as you see here. This is the antenna. Okay, and this is the receiver where the data will be stored, and this has got a monitor which can be detached. This monitor is basically to interact with this hardware, right? This can be placed it over here. Okay, and apart from this there are some other accessories like the connections for the antenna and the receiver. This is the wire, and in order to connect the battery there is another wire given here, and then there are some other accessories which provide the flexibility to place it over the tripod. Okay, so now we will be establishing the base station. That is, as we have already discussed, the basic operations at the base station will be centering, leveling, and then configuring the instrument. Right, now we will be centering and leveling the tripod. Rotate. Okay, so now I am trying to establish a base station over the base point, right? For that, first the operation you have to do is the leveling, centering, and then configuring. So now I am trying to explain how to do the leveling. Okay, so just place this tripod over the base and try to adjust the height as you feel comfortable. Okay, so just by visual you have to adjust this, you have to see that this plane is almost horizontal, right? Or else you can take the help of pen also, right? So take a pen which can roll and say place the pen here. So this will tell you where is the lower side. So now this pen is going this way, so I need to just adjust this way. Okay, so by this we have just done the course level of leveling, and then here is a dry batch, so which has got a spirit bubble. This bubble will help me in doing the fine leveling. Okay, so I'll be placing this over here. Apartment. Okay, So this try batch has got 3 screws which will help me in fine tuning the leveling process. Okay, now you see the bubble here, bubble दिखाइए, right? So this bubble we have to bring it into the circle of this, inside the circle. Okay, for that I have to do the fine leveling. So I'll be doing it with the help of 3 screws. Okay, so for that you take any 2 screws and try to rotate it either inside or outside depending upon the movement of the bubble. Okay, so after fine tuning with these 3 screws, then I could successfully bring this bubble inside that circle, which tells me that the leveling of this instrument is done to a finer level. Okay, so after that I should also ensure that this instrument is placed exactly over the base station, right? That is nothing but the centering. For that there is an optical plummet is given, right? From here I can see, right? So uh, if this tripod is not exactly over this, then I need to shift this tripod. Okay, so once I shift the tripod, the leveling again goes out of shift. So again I need to do this leveling process. So we understand that this centering and leveling is an iterative process. So band kar dijiye. So after now we have done the centering and leveling part. After that now we will be mounting the antenna over this tri batch. So for that there is an accessory called the antenna mount is given. So this is the antenna mount. Right. So this is the antenna. So at the receiver you have got the different ports. So this port is for the antenna, this port is for the power, and this is the extra port, and these are the power ports. Okay, okay, so now I have attached the antenna with the receiver. Now we need to give the power support to the receiver. Okay, so this receiver has got a data card. So here the data will be stored in this PC card. Okay, so मेरी तरफ So now we have done the basic operations, two of the basic operations, that is the centering, leveling and mounting the antenna, and then doing the connections between the different components. So now the receiver is ready for doing the configuration and starting the GPS survey. Okay, now we have to switch on this instrument. Either the switching on can be done from this or from here. So once you switch on, this is the welcome screen, and here you see the different options available for it. Right here you see a person carrying a pole, and here it is showing you the number of satellites that will be visible, and here you will get the number of satellites that are transmitting or being tracked in L1 and L2 signals. Right, this is showing the PC card status, and here this is showing the battery status. Okay, so here there are different options to configure this instrument as per your requirements. Right, so in configuring and starting the survey, there are three things we have to do for. One is the configure the instrument. Right, this is configuration, nothing but informing the instrument how it should function. Right, you have to just browse to that and press enter. So once you press enter, then the already present configurations will be present here. You can either continue with the present configuration, or you can make a new configuration. You can edit the configuration, you can delete the configuration, you can get the information from the configuration, and you can also search for the configuration using this button. Right, so these are the different options, and the buttons just below this will facilitate you to access those options. Right, so here now we'll try to make a new configuration. So for that, this is the new, and you have to just press this button F2. So just press this button F2, it will ask you for the new configuration. So here it is asking me for the name, like I just give it as demo. Okay, here you can add some description about this configuration, and then you can also give the name of the creator. Right, and then just press on continue. Now it is asking me the mode in which it has to function. Right, so here there are two modes. One is the advanced mode, and another is the standard mode. Standard mode is nothing but this has got some of the default configurations. Okay, so generally we go with this advanced. Press on continue. Okay, now it is asking me the configuration for the antenna type. Right, so if here you see the antenna name, so the different options are available. So accordingly you have to choose the antenna that you are using. So the antenna that we are presently using is this AT501 tripod. Just select that antenna and then press on continue. Okay, then it will automatically take this vertical offset. So this here the vertical offset for this antenna is 36 centimeters or 0.36 meter. Okay, now here we have to provide the antenna height. Right, so here in our case the antenna height is 1.2. Right, and what was the type of measurement this antenna height was measured? So in this you have both. One is the slope measurement and another is the vertical. So the measurement which I have done is the vertical. So in vertical the antenna height is 1.2 meters. Okay, just press on continue. Then it will ask for the position type, that is how much should be the update rate of the receiver. Right, you have to select here the different update rates. So here the update rates vary from 0.1 to 60 seconds. So generally we do for 1 second, and now it is asking me to configure for the coordinate system. So since no transformations have to be done, then I keep the coordinate system as the WS84 geodetic, and then press on continue. So now it is asking me the format of the data that it is going to provide me. So I can configure it as easting, northing and height, or northing, easting and height. So this just depends upon the ordering of the position. Okay, in case of latitude, longitude, then first will be the longitude, and then latitude, and then height. Okay, just press continue. Then it will ask for the real time. So as we have already discussed that in order to do the real-time survey, we need to have a modem at the base and a separate antenna to receive the corrections from modem at the rover. Since we do not have that setup, we have to go with this real time as none. Just press continue. Now it will ask for the logging. That is, logging is nothing but storing the data that is received at the antenna end for a given update ratio to be stored in a file, right? Yes, it is asking me for log static observation. Then here the options are yes or no. So since we are taking this observation in static, I have to go with this yes, and the observation rate is 1 second, yes, and then log moving observations. If the antenna is moved, should that reading be recorded or not? So since it is a base, generally we go with this no. Okay, press continue. So it is just giving a warning that whenever the antenna is moved, either manually or due to the external forces, it will not be recording the readings. Okay, so just accept this warning. Then it will ask for the occupation settings, right? In this you have the occupancy mode. In this mode you have the instantaneous and normal mode, right? Instantaneous is nothing but whenever you just move and place it, then it will record, and in normal case it does as per our configuration. And the other is the auto stop, whether it should whether this receiver should stop automatically or it should be only in a manual mode. Since it is a base, I would prefer to have it in a non-auto mode, right? Just press on continue, and then the ID template. ID template is nothing but the point ID template in which it will be storing the points. Like here the occupied point will be stored with respect to the time and date. Similarly, you can select the different available templates or you can make your new template. And then press on continue. Then it will ask for the DOP limits. DOP is nothing but the dilution of precision, which you might have already studied in your theory discussions, right? So here you can set the different values. Like the default value here it is set as 20, so let us go with the 20, right? Disable height phase, yes, since it is a static mode and it is also the base setup, generally we go with this height disable as fixed. Press on continue. Then it will ask for the offset, whether there is an offset or no, right? So since there is no offset, let us go with the configuration available. So now with that we have done the configuration of the instrument, right? So the demo was the configuration, so we'll just go with it. Okay, so now we are done with the configuration. Now we just need to create a job file. So for that, just press the up arrow and then press on continue. Okay, after that, then these are all the jobs already done. If you want, you can create a new one. Enter, continue. Okay, continue. Okay, so and then you are also now done with creating a job file. After that, you have to go to the GIS data collection, press on continue. Okay, then it will automatically take the configuration as demo, job file as demo, the coordinate system is WGS geodetic, okay, and the antenna type is 8501 tripod. Okay, here you have to give the code type. Since it is a base, we do not need to create a large code list, so I just go with the already present code, that is base. Okay, so now if you see here, by this time the satellites available are 8 but tracked are only 1 in L1. So we have to wait for minimum 4 number of satellites in order to occupy this point.
Ready.
Okay, so now you can observe here that the number of satellites that are available here are 8 and the satellites that are tracked are 8, right? And also you see after getting the minimum 4 number of satellites, you will get a precision mark, this plus mark, right? After getting this right precision mark, you have to just press on occupy, right? So once you occupy, you see there is a change in the symbol, right? So we have started this survey in a static mode, so you get a tripod symbol. Otherwise you have a person standing with a pole, right? So here, and if you want to stop the survey work, just you have to press this F1, which is just below the stop, right? So now we have started the base. So with this we have done all the procedures that are to be done for establishing a base station, right? So if you want to see some parameters, then you have to press on status. Once you press on status, you have different options. One is data logging, data collection, logs, general and interfaces, right? So we will go into the data collection. In that you will be able to see the real time, right? Since we are not doing the survey in real time, you will not be able to see any data. So I'll just try to show you the position here. Go to the option of position and then press on enter. Then you will be able to see the latitude, longitude and the height. And also you should remember that this height is nothing but the ellipsoidal height, but not the mean sea level height, right? So this is one. And if you want to see the number of satellites, you can see here these are the satellite numbers 32, 31, 20, 16, 1 and 14, and these are their respective elevations and azimuths. And this SN1 this SN1 is nothing but the signal to noise ratio of the signal L1 tracked. If it is able to track the L2 also, then you will get the SN2, which corresponds to the signal to noise ratio of the signal L2, and these are the quality parameter of that particular satellites. So with this we have completed setting up the base station, which is nothing but placing this tripod just above the base station. We understand that the base station is nothing but the place where we know the coordinates, that is latitude, longitude and elevation. So with this we have completed setting up the base station, which is nothing but placing this tripod just above the base station. We understand that the base station is nothing but the place where we know the coordinates, that is latitude, longitude and elevation. We have mounted this, and then we have done the arrangement for connecting all the components of this receiver, and then we have also configured the instrument, right? So we have started the base station. After this we will be establishing a rover station. There we have to find out the coordinates of the base rover to a higher level of accuracy. So now we will move to the rover station, which is placed just down station. Hello, now we will try to see the third laboratory exercise, that is mobile mapping, right? Mobile mapping, you have to collect the coordinates of the either line or polygon or the points while moving, right? So unlike your earlier exercise, which was dealing with only collecting the static coordinates of the rover to a higher level of accuracy, whereas this laboratory exercise will be collecting the different features like line, polygon and the areas. Okay, so for that we have got the Trimble receiver, right? You see this is a Trimble. This receiver is made of Trimble with a Geo XT antenna, and the product is Geo Explorer 2008 series. So for this mobile mapping unit, this will act as a base station. Okay, so we will be placing this base station over a base point. And then this is the unit for the rover, right? So with this PDA we will be collecting the rover points, that is line, polygon and areas. Okay, now I will demonstrate how to handle this instrument. First we will start with going with a base, configuring the base. This base has got screen monitor here, and okay, so now I'll try to explain you how to use this instrument and set up the base station, right? You see here a screen given, and to interact with this touch screen, there is a stylus given here, and just you have to press this button to switch on it. Now you see the screen here, and go to start, and then in the start there is a software called TerraSync. Okay, just invoke this software. So now we will try to see how to configure this base receiver, right? You just on pressing this, you will be able to see the screen, right? Here there are different options to make use of this receiver. So we will be invoking the software which will be responsible for collecting the GPS signal. Just click on start, then you have different options, right? You see the software here, TerraSync. Just click on this software, Now we are invoking the TerraSync software. You see, as soon as I invoke this, there was a message called the almanac received. That is the signals. It could track the satellite signals and it could extract the almanac information. With that almanac information, it is able to plot the number of satellites. That is, you see, there is a possibility of getting a satellite 20, 32, 31, 1 and 16. Right. So once it collects the ephemeris data and the other coded information from the satellite, it will be able to process that. For the time being, let us browse the different tabs of this. Now you see a status here. Just click on this, you will be able to see different options. That is, one is map. If you just go on map, you will be able to see the different features that were captured on this. Since we have not captured any feature, it is a blank sheet. And if you go into data, it will provide you flexibility to make a new job file. You see here, you can configure the type. Since we are making it base, so you have to select this as the base. Okay, and the location is default, in the sense it will be defaultly stored in this memory of this. So here you can give the name of the file. So let me write it as BASE, base 1. Okay, and then I'll just click on this create. So now it has created this file with the name demo1, base 1, sorry. So it will ask for the antenna height. So the antenna height here approximately is 1. So now click so the antenna type here is the GeoXT internal. So we have seen this is the GeoXT. So this is the internal antenna. Just press on next. So here it will ask for the logging interval. So after how much time it will be able to record each position. So let us take it as 1 second itself. So the DOP type is PDOP, it is taking it as, and here also you can define the minimum elevation angle, right? You can define as per your requirement. So let us, for the time being, let us now go with the file. So here you can also define the minimum SNR, right? So the output, we are not going to send any output, so let us keep it as the off, because we are not doing this survey in a real time mode. Just click on next. So you have to provide the coordinates of the base station. Yes. Okay, so now you can see that the number of satellites that are tracked here are 4. However, we are also supposed to get more than 4. So I have entered the coordinates for this base station as this. So let me click it as OK. So it says that the position is within the accuracy of 100 meters. Further, it will improve the accuracy. Okay, so with this we have started the base station, right? If you want to see, you can see the status. That is, these many satellites, you see the blank satellites with black background. These are the satellites that are tracked, and these are the satellites that are visible. And this is the present coordinates of this base station. Okay, so further you can also see the satellite information. That is, these are the PRN numbers, and these are the SNR values for each, and this is the elevation angle, and this is the azimuth angle of each satellite. Okay, further you can also see the information about the receiver here, right? And further, this is the sky plot, right? So with this we have almost set up the base station. And further, if you want to make any changes in the the logging setting, GPS setting, coordinate system and units, if you want to change anything, then you have to go into the setup and then suitably select all of this and then configure accordingly. Okay, so with this we have almost done the setting up of the base. कर देता हूँ. So now the base station is almost established for doing the mobile mapping in differential mode, right? So now we'll move on to the ground for collecting the different features, that is line, point and area. So now we are in the field to collect the different features on the ground. So in this laboratory exercise I will be demonstrating how to collect point, line and polygon. Right, to start with we will be plotting this pole first, and then we will be also plotting one line and another two polygons outside. Right, so for plotting I have this Trimble made Juno. Right, so in order to operate this, just you have to press on this button. Okay, so this will make it on, and then similar to your base, it has got a start menu. Click on the start, and the similar software, that is TerraSync. So the instrument now is ready to operate for the software. You have to just click on this start button, then you have different menu options. So in order to get the data, satellite data, you have to just invoke this TerraSync software. So the setup and all are almost same to the base receiver. So all the menu buttons and all are same. Here we still did not get any almanac information or the satellite data. So it is showing you the 0 satellites. So there are no latitude, longitudes and height values are given here. Okay, so the menus and sub menus are almost same. There is no change in it, right? So as a first option you can go to setup and then do the setting up for logging setting, GPS setting, real time. We do not have the setup for real time. So if you want, you can change the coordinate system, units, and also if you want, you can attach some external sensors to it, right? So now what we do is, this is the map area. You see here we have not collected any feature at all. So but once we collect the feature, you will be able to see different features here. Okay, so now we'll try to make a file. Go to just click on this, go to data. So now it will ask for the file type. Yes, it is a rover file, right? And the location stored is default, and the file name, let me give it as demo space rover. Okay, so then press on create. It will ask for the antenna height. So antenna height is approximately 1.2 meters and the antenna type is Juno. So now once you make a file for the rover, it will ask for the type of feature that you are going to collect, like point, line and area. So I will be demonstrating you how to collect these three features. Right, to start with, we'll first start with the point. Okay, so you see now the number of satellites that are visible are 4 here, right? So now let us collect the point feature. We are collecting it for the electric pole, right? So I'm selecting this feature, and just click on the create. So once you click on create, it will facilitate you to log the data. Okay, just click on log. So now it is logging. So you see here the number is getting increased. This is getting increased for each log. Okay, so if you want, you can add some comment here, like say suppose this is the electric pole. Right, so let us make the observation till 50 epochs, that is 50 observations. Click OK. So now you will be able to see the feature is stored. If you want, you can see it on the map. So this is the feature, right, point generic, and the attribute that is I have given it as the electric pole. Okay, these are the coordinates of this pole. So now we will collect the one more point feature. So here we are now going to collect another feature. Right, so here you have to select the points and then again create. Okay, so I can add, so now it is collecting the data for the second point feature. So let me add it as corner. Corner pole. Okay, so we will collect here 30 readings. Okay, so now this feature is stored. So now we have collected 2 points. Now let us collect a line. So for that you have to select on line generic and then click on create. Okay, and then log. Okay, so the comment that you can give here, say suppose I am now collecting the road. Okay, so now your data is being logged. You can see a line here. So now we are mapping the road. जितना है उतना ठीक है. Okay, this is the road, and now we have collected the data for the road, right? The feature for the line is stored here. Now we'll try to collect the polygon area. So here is a ground, so we'll try to map the boundary of this ground. Okay, for that you have to click on this area and then click on create, right? So I'm just logging. So we are moving on the boundary of the area. साइड ठीक है, आप मेरे को कवर कर दीजिए, मैं ऐसे चलता हूँ। नहीं, आप मेरे को कवर करिए, मैं ऐसा मतलब वॉकिंग टाइप का।
सर इंस्ट्रूमेंट इधर दिखाइए, इस हाथ में ले लीजिए, मैं इंस्ट्रूमेंट भी दिखते रहेगा। So here you can see one polygon is been mapped. So that is nothing but the garden which I have mapped recently, just now, right? So I will just end this feature collection. Okay, just say it as garden garden 1. Click OK. So now this feature of polygon is been stored. Similarly, you can collect n number of features, n number of lines, and n number of polygons, and doing a mobile mapping with this. So after all the features are been collected, now you can post process it using the base data and get very accurate mobile mapping. So this is how this is the procedure to make use of a rover mobile mapping unit. अभी मैं जाऊंगा तो कभी इंस्ट्रूमेंट फोकस या वो
చాట్ మూవీ అయిపోయింది సార్ చాట్ మూవీ కిడ్నీట కొట్టండి పూలు పడతాయి కిడ్నీట కొట్టండి నేను నాకే తీసుకుంటాను పూలు వేసి హీరోలు వచ్చాయిగా హీరోయిన్ వస్తుందా హీరో వస్తుందా
ठीक है सर चलिए on करो on है so here you can see the two polygons which were mapped. This is the garden 1 and this is the garden 2, and along with this these are the polygon features that we have mapped, and here is the line polygon which we have tracked the road, and you can see the 2 point features also we have mapped. Right, so this was the point feature, that is point generic point type, and the attribute that I have given is this corner pole, and these are the easting, northing and elevation of that particular point, and this is the line feature that we have mapped. Further we have also mapped the area polygon, so this is the road, that is line feature. And these are the polygons which we have mapped. So this is the procedure to collect the rover mobile mapping unit. Okay, so now we are in the field to collect the data for the rover station, and this is the pole and antenna already mounted, and all the components of this receiver are been connected. Now I will show you how to use this instrument as a rover. However, all the procedural will be same as that of base, that is you will be doing the centering, leveling and the configuration of the instrument. The configuration and all will be similar to that of the as establishing the base station. Right, so now we will see how to do the configuration here as a repetition of the base. So once you switch on this instrument, the main screen will have the different option similar to that of the base one. You see here the almanac has given the information that 5 satellites are available here. Since this is a L1 single frequency receiver, we are only tracking the L1 signals. L2 no L2 signals are being tracked. Since the number of satellites are more than 4, you have also got this precision mark. That means to say that this instrument is ready to get the data. Okay, similar to that of configuring the base station, you have to browse to the configuration and then press on the either on enter or on the continue, right? So then it will take you to the menu of all the configurations. Either you can use any of them, or if you want you can create a new one. So I'll just try to tell you how to create a new one. Just press this button F2, which is below the new, and write the name, say rover 1, press enter, and if you want you can add the description. If you want you can also add the name of the creator. Press enter, press continue, and similar to that of the base, now it is asking me for the mode of this configuration. So we generally, as I already discussed, we generally go with the advanced. Continue. Now it will ask for the type of antenna that I am using. Just press on it, then it will take you to the different available receivers, antenna poles. So here we are using AT501 pole. Just select that and press on continue. Okay, then it will automatically take the antenna height as 2 meters. So the whatever the pole you have seen here, it is a 2 meter, and the measurement is made in a vertical direction. So just press on continue. Here you can give the update rate as we have given for the base. Let us take this update rate as 1 second, and we are not changing any thing for the coordinate system. Press on continue, then it will ask for the format of the data that you are going to get, that is whether you want the easting first or northing first, and in case of this geodetic format, whether you want the longitude or latitude first. Okay, and press on continue. Since we are not doing this survey in a real time mode, we have to keep it as none. Press on continue, and then it will ask for logging the static observation. Yes, we are doing this survey in a static mode, so it should be S. And you can also give the observation rate, but let it be at as 1 second. And since this will be moving, so let us also record the moving of the antenna. So whenever we move the antenna, the data also will be recorded. Okay, now it will ask for the occupation setting, that is whether the set occupation in a normal mode or in an instantaneous mode, and this is for the auto stop, whether you want this instrument to be shut down automatically or you want to do it manually. So generally we go with the manual setting. Right, occupancy template, that is ID template, how you want your point template to be defined, whether you want to define your own or you want to use any of the already present. So generally we go with the time and date. Continue. So it is asking for the dilution of precision limit. Generally we give it with the GDOP, right, and the limit is defaultly set as 20. Okay, now it is the navigation mode, whether we are disabling the height or not. Yes. So we will not be changing the height of antenna, so let the height be disabled and press continue. Yes, there is no offset, so let us not worry about this, and we are done with the configuring this instrument. So this is the configure we have done, rover 1 created by Raghav, and we are going with this configuration. So we are done with the configuring the instrument. Now we have to do the job file creation. Just browse to the job file, and then here is the menu to use the already present job file, or if you want you can create a new just by pressing the button which is below the new. Let me give the name it as rover 1, press enter, and all the data will be stored in a PC card. बंद करिए इसको थोड़ा. So this is the job file which we have created, rover 1. We are continuing with this job file. Okay, so now okay, so now for collecting the satellite data, you have to browse to the GIS data collection and then continue. So it automatically picked up the configuration set that we have created it as rover 1, the job file rover 1, the coordinate system that we are using is WS84 geodetic, and the code list that we are defaultly taken it as NHRDM3. The antenna type we have set it as AT501 pole. Okay, so here since this rover is for the different feature collection, so you have the feature list which is nothing but the point line and area, right? So we will be collecting the point lines. Okay, for that you have to create a new code. Let me write it as point 1, point code P1, enter, continue, and okay, sorry, continue and store. Continue, continue. Now you see there is a precision mark, and we have enough number of satellites, so just press on occupy. Now your mode has been changed from kinematic to static mode as we have set in the configuration. Now this receiver is collecting the data. If you want to see the data, you have to go into the configuration button data collection, and the data collection, if you want to see the position, you have to just select that. Position.
Ready.
So now we are collecting the data with this rover. If you want to see the data, just click on this status button and go to the data collection, and here different options are available. So if you want to see the present position, you have to select that position and press enter. So now you will be able to see the latitude, longitude and height as this, which are being updated for every 0.1 second. Okay, so if you want to see the satellites that are being tracked, go to the satellite option and press enter. You will be able to see all the satellites. Satellite number 32, 16, 20, 23, 31, 13 are being presently tracked, and these are their corresponding elevation, azimuth and signal to noise ratio. Okay, so further the data at the rover will be collected for sufficient time, say 30 minutes to 1 hour, and further it will be processed using a software along with the base data, which will improve the accuracy of this rover. So this demonstration will be done in the lab further using a software called Leica GeoOffice or Ski Pro. So once you are done with capturing the collecting the data for sufficient amount of time, you have to switch off this instrument. For that you need to go to this menu and then press on the button which is just below the stop, that is F1. So this will stop the data collection. Further, if you want to collect the different features, you have to select on feature, select the particular feature and then further proceed the step as explained earlier.